There it is. There it went. There it is. All right. What we are doing today takes what we did the last 3 lessons, and we're actually going to use it to create something. There's very, very minimal amount of graphing with this, and it's different graphing than usual. Okay, it's like points. It's not that bad. Don't look at me like that. It is not that bad. Okay, so all the matrices we're going to have today will only have 2 rows, and that's because every column is going to be a point. Okay, so that first column will be a point x1, y1, and then the next column will be a point x2, y2, and then if we have more columns, each one will be a point. That's how we're treating today's matrices. They're not always going to be like that, but that's how we're treating them today. Okay? We're going to go through and talk about all the things we are learning to do today, and then we will go and actually do them. Okay, we're not going to talk about it, example, talk about example. We're just going to talk all about it and then do examples. Okay. So for a translation, we will create a transformation matrix and add it to the original matrix. Now for transformation, let's say we have a shape and it looks like this. Okay, for a translation, that means we're either going to move our shape up, down, left, or right. Okay, that's what we're doing.
Don't you usually just flip it over the axis?
We will do that down at the bottom with reflection. Okay, so for translations, we're just going to add matrices. We'll create a matrix and add it to the original. Now the next thing is to change the size of our shape. If we want it to get bigger, we dilate it. Okay, dilation can be big or small. So what we will do with that is we will multiply the original matrix by the dilation factor. Say we want this shape to get 3 times bigger. We will multiply whatever matrix goes with this by 3. If we want it to shrink, and become half of its size, we would multiply it by a half. Okay, so that operation is scalar multiplication. That's what we did in, what was that, Friday? Y'all liked that. I think you thought it was pretty easy. Okay, so that's when we want to just change the size. We kind of keep it where it is, we just change the size. All right. So those 2, pretty simple. The next thing is a reflection. So this is what Kobe was talking about earlier. So we can reflect it over the y-axis, which means we take this shape and we flip it over here. Okay. Over the x-axis, we'd flip it down. And it's not just moving it, it's actually flipping it. Okay. The line y equals x is this diagonal, kind of. It goes through the origin. So we'd flip it over that line. It's not going to let me do it. The line y equals negative x is the other diagonal. Okay, so we'd flip it over that line. Now the way we do that is we multiply the original matrix by the appropriate matrix. What I mean by appropriate is whichever one of these it tells you to use. Okay, if it says reflected over the y-axis, you're going to use this one. When you do this, order matters very much or else it won't work. You have to do the reflection matrix and then the original when you multiply. Otherwise, by the dimensions, it won't work. So order matters for sure. Now, that was reflections over axes and lines. The other thing we have is rotations. So for rotation, we can either rotate 90 degrees, 180 degrees, 270, or 360. And they're always counterclockwise. Okay, that's what we're doing in this class, is counterclockwise. So if we wanted to rotate this thing, let's say 180 degrees, we'd go counterclockwise 180 degrees. Okay, so we're just twisting the shape, basically. If it's 360 degrees, if you rotate something 360 degrees, what do you end up with? The same thing you started out with, right? If I take this and I rotate it 360 degrees, I end up back where I started, right? Remember that. Might help you on your homework. All right. So these work pretty much the same way the reflections do, and that we're going to multiply the original matrix by the appropriate one. And same thing again, you have to do the rotation matrix first and then the original. On the test that you will have like middle of next week, I will give you these 8 matrices with what they go with. You do not have to memorize these. It's lots of ones and zeros. Okay, you do not have to memorize these. I will give them to you. You okay with that? Okay, y'all are really exciting. Okay, so let's go to the back and actually do some of these examples. All right, so the first one, let's go ahead and graph the original. Okay, so let me make my axes. You do that too. Nope. Almost got it. Okay, so my original one, my first point, what's your first point going to be? 2, 0. What's your next point? Negative 3, 1. Having trouble with my dots. Okay, and then 6, 1. And 4, negative 4. And then you can connect them. You're always going to have a shape. You're never going to have your lines cross. Okay, so outline it to where it makes a shape. All right, so that looks like a weird like boomerang thing or something. Now it's told us to dilate it by 2. So based on the front, if we're dilating, if we're changing the size, what's our operation? We're going to multiply it. Do we multiply it by matrix or by what? We're going to multiply it by 2. So take 2 and we'll multiply it by that matrix. So what's that resulting matrix going to be?
4, 0, negative 6, 2, 12, 2, 8.
Whew, sorry, I got behind. Okay, 4, 0, negative 6, 2, 12, 2, 8, negative 4. Okay. Negative 8. Sorry. Then you just graph it. So it should be the same shape, just bigger. So let's see if that worked. The 12 is kind of off the grid there. 8, 9, 10, 11, 12. kind of estimate that one.
It's kind of hard to see where it points.
So like I said, it should be the same shape, just bigger. If we had multiplied it by like a fraction or something, then it would have gotten smaller.
Mine's kind of the same shape. I think I was.
Now for the next 3 examples, we're gonna kind of change what the notes say because your homework has like 12 problems on it, and we're actually gonna, instead of doing these 3 examples, we're gonna do 3 of the problems from your homework. So let me pass out your worksheet and then we'll keep going. It does. All right, so your homework, there's not really room on the page for you to do the work. So you're going to have to do your work on a different page. But what I want you to do is put the matrix you end up with, your answer matrix, somewhere by the problem, and then you'll also graph it. Okay, so on your homework page, I want the resulting matrix and, of course, the graph. You can do your work on a separate page. We're going to do the first 3 problems together. I recommend going ahead and doing them on your notes so that that work is there and you don't lose it if you need to come back to it. So instead of what our notes say to do right here, we are going to do the first one from the worksheet, which is the matrix is 0, 1, ooh, I wrote it wrong already. 0, 1, 3, 2, and then 4, 4, 0, 0, and we are supposed to move it 1 unit left. That's supposed to say left. And 3 units up. All right, so for this one, since we're just moving it left and up, it's a translation. So how are we supposed to do the translations? We're supposed to add. So if you think about it, your x's are all on top, right? So our x's on the graph, those will move 1 unit left. So what number should we add to all those values? If we're moving it left, we're going to add -1 because we want them all to be 1 less than what they are to all of them. Okay, and then what about the y's down there on the bottom? What do we need to add to those? That says 3, sorry. 3 units up, so we need all those values to get bigger, so we're going to add 3. So when you have a translation matrix, it'll be the same size as your original one, and all the numbers on top will be the same, all numbers on bottom will be the same. Now what those numbers are depends on how it wants you to move.
That is so easy.
So what is the resulting matrix? Take 0 plus -1, so we get -1. 1 minus 1 is 0. 3 minus 1. 2 minus 1. And then 4 plus 3, 7. 4 plus 3 again is 7. 0 plus 3 is 3. 0 plus 3 is 3. Now, on your homework, you do not have to graph the original. Only graph the one you end up with. So, yeah, write this on your paper somewhere close to the first problem. Okay, so write the answer on your paper and then graph it. You can just graph it on your homework. You don't have to graph it on your notes if you don't want to. So I will go ahead and graph it. Notice that your graph goes by twos.
Yeah, so what if it's -1?
Then you will go halfway to zero.
Nee.
Alright.
Yeah.
The shape is kind of weird,
Yeah. Yes, it is like a parallelogram. It is very hard for me to
Where'd my other dog go?
graph it on here. It's kind of annoying.
Oh crap. I didn't put negatives on my thing.
Okay, so it makes a parallelogram. It looks something like that. Yes, we're gonna do number 3. Oh, it's echoing now. Do not echo. Okay, it's not echoing. Alright, so we're gonna do the third one off the homework. So instead of the rotation of 180 that's on the notes, we're doing rotation of 90 with this matrix. Alright, so for rotations, what do we do? Do we add? Do we multiply? Do we blow them up? Huh? We multiply. What are we going to multiply by?
The original.
0, 1.
Okay, so you saw the rotation matrix for 90 degrees on the front of your notes. Do we put that in front of our original or after our original? In front. Okay, so I'm going to fit this in. So it was 0, -1, 1, 0, like that. Now let's see if y'all remember how to multiply from yesterday. What my resulting matrix, let's see, this is a 2 by 2 multiplied by a 2 by 4. So what is my resulting matrix dimensions going to be? 2 by 4, because we take the outside numbers, 2 by 4. All right. So for row 1, column 1 spot, I take my first row multiplied by my first column. What's 0 times 4? 0 plus what's -1 times 0? 0. So what's 0 times plus 0? 0. That one's not too bad, right? Okay. In my next spot here, I take first row, second column. First row, second column. So it's 0 times 5 plus -1 times 0. We get 0 again. Okay, next one. 0 times 5 again. 0. -1 times 2. -2. So 0 plus -2 is -2. If you would like to write out more work, go for it. I'm not going to stop you. Okay, what's the last element on that top row going to be?
0 times 4, 0, so -2 again.
-2 again. 0 times 4 is 0 plus -1 times 2 is -2. So that ends up with -2. Okay, so we got the top row.
On the second row,
Second row, what are you going to get?
0, 0,
1 times 4 is
4.
4 plus 0 times 0 is just 4. 1 times 5 is 5 plus 0 times 0 is 5. 1 times 5 is 5 again plus 0 times 2. 1 times 4 is 4 plus 0 times 2 is 4. So our top and bottom rows switched, and then the top row became negative. So make sure you write this down on your paper by the third problem, on your homework paper by your third problem, and then graph it. Should be a rectangle that kind of connects to the parallelogram.
Do you have to do it on one graph?
You're gonna, for your homework, they all need to end up on one graph. Because it makes something. It reveals a word, as the instructions say. Last one on the notes. Instead of doing what it told us, let's do the second one from the worksheet. So we're gonna reflect in the x-axis, and we are going to use the matrix -2, -3, -1, 0, -3, -3, -7, -7.
Positive 7. Reflection in x-axis. Oh yeah, -7.
So what do we do for reflection in the x-axis?
1, 0, 0, -1.
Okay, what do we do with that?
In front of it, multiply.
We're going to multiply it in front. It's going to be 1, 0, 0, -1. We are getting these matrices from the front of the notes. Okay, so you're going to want to keep those handy while you're doing your homework. And remember, I will give you those matrices on the test. You'll still have to go pick which one you're going to use, but I'll give them to you. So from here, we're going to multiply again. We're going to end up with same size matrices as before, 2 by 4.
So 1 times -2 and 0 times, so -2.
The first one will add up to get -2. Very good. What about the next element?
-3.
On a roll, keep going.
-1.
Yeah. So on all those, you multiplied 1 by the top number and added it to 0 times bottom number. 0 times all those bottom numbers just canceled out, so all we had was the top left, basically. Okay, so what happens on the bottom? 0 times -2, 0 plus, what's -1 times -3?
3.
Positive 3. Okay, keep going. Tell me what you get.
And then 0 times, so it's +3.
Positive 3 again.
Positive 7.
Positive 7. So on that one, this 0 made everything on the top not matter, and all we had to do is multiply the -1 by what was on bottom. So just change those signs. All right, so write that matrix down on your homework paper, and then go graph it. I'll graph it on my graph. You graph it on your homework graph. Eee. I'm going to have to zoom in. Hey, so what do you see? It's an A. If you want to go and color this stuff in, I'm not going to stop you. If you want to make it all pretty or something, go for it. Do you have any questions? No? Okay, so that means you only have 9 of these left.
Wait, mine's not.
Huh?
Mine's like opposite.
Oh, that's weird. Hold on.